This videotape will show you the basic parts of the horizontal milling machine and how they function in machining operations. This machine generally comes in two types, plain or universal. On the plain milling machine, the table can move longitudinally, transversely, and vertically. On the universal milling machine, the table moves in all these directions and can also swivel up to 45 degrees for angular milling. In manufacturing applications, the basic horizontal milling machine may be set up for specialized operations. For this demonstration, we will use a universal horizontal milling machine, one of the most versatile and useful machine tools. After viewing this videotape, you should be able to state the safety procedures used in the machine shop and in the operation of a horizontal milling machine, identify the basic parts of a horizontal milling machine, and describe the function of the parts. Before operating any machine, observe proper shop safety practices. Always wear safety glasses. Remove rings, watches, and other jewelry, and keep sleeves rolled above the elbows. This horizontal milling machine is a knee column type, so designated because of its vertical column and projecting knee-like casting. The knee with its accessories allows the table movements that make the horizontal milling machine so versatile. The base and column of the horizontal milling machine are usually one heavy casting, which supports the other components of the machine. The casting is generally hollow with heavy walls, leaving space inside for elements such as the main drive motor and coolant reservoir. Precision machined ways on the front face of the column allow the knee to move up and down. The column also holds the controls for operating the machine. The spindle is machined into the head of the column and transmits power for rotating the arbor. The arbor holds and rotates the milling cutter. The overarm, located at the top of the column, supports the free end of the arbor. It moves back and forth to support arbors of various lengths and can be clamped tightly in place with locking nuts. On the end of the overarm is the movable arbor support, containing a bearing which supports the free end of the spindle. This support prevents the outer end of the arbor from deflecting upward under cutting pressure. The arbor is held in the spindle by a drawbar and nut, which pulls the tapered arbor sleeve into a matching taper in the spindle. Keys in the spindle fit into keyways on the sleeve to provide rotating power without slippage. There are two styles of arbors. The short arbor, called the stub arbor, holds and rotates the cutter without the overarm support, and the long arbor uses bearing collars and the arbor support. The bearing collars ensure the correct fit in the arbor hole of the support. The controls found on the column set the speed and direction of the spindle. They usually include a variable speed selector, a high-low range lever, and the spindle forward and reverse switch. The start-stop controls the main motor. The knee holds all the other parts of the horizontal milling machine. It is supported on the base by a heavy screw, which gives it vertical travel. The knee can be moved up or down with a vertical hand crank or the vertical power feed lever. The saddle sits on top of the knee. It provides support and transverse travel to the table. The saddle can be moved toward or away from the column by using either the cross-feed hand wheel or the power cross-feed lever. The table sits on top of the saddle. It can be moved longitudinally with the hand wheel on the end of the table or the longitudinal power feed lever on the front of the machine. The rate of travel on the saddle cross-feed and the table is controlled by the feed range control. T-slots are machined into the top of the table for holding vices for clamping the work to the table. The table is also equipped with table stops to stop the table automatically when machining. When the power feed lever is engaged, the rapid traverse lever, located on the front of the machine, can be used to speed up the travel of the table. This feature is convenient for making machine setups, but should never be used to pick up cuts. All the sliding components on the knee are equipped with clamping levers. The saddle clamping lever locks the saddle. The table clamping lever locks the table. The knee itself can be locked to the ways on the column with the knee clamping lever. It is important to lock any component that will not be moving during a machining operation. Milling machine arbors are equipped with self-releasing tapers, which usually have an included angle of over 15 degrees. The most common milling machine arbor has a number 50 National Milling Machine taper. This steep taper permits the quick removal of the arbor from the spindle nose. When mounting the arbor in the milling machine, clean the hole in the spindle nose and make sure that the arbor itself is free of chips. Place the arbor in the spindle nose with the keyways lined up with the drive keys. Screw the drawbar bolt into the arbor. Then tighten the nut to pull the drawbar and arbor into the spindle nose. This aligns the arbor into the spindle nose and holds it tight. A key is inserted into the arbor to drive the cutter. The cutter is positioned on the spindle by using spacing collars. Then the cutter is placed on the spindle. Then more plain collars are added. The arbor bearing collar is then positioned on the spindle, and the spindle nut is tightened against the bearing collar. The arbor support is then placed on the overarm and the bearing positioned in the arbor support. Now clamp the overarm in place so it will not move back and forth during machining operations. When using the arbor support, always make sure that the oil level in the arbor support is sufficient to give lubrication to the bearings. The horizontal milling cutter is now set up and ready to machine a workpiece. To review this videotape, you should now be able to write down the safety procedures for horizontal milling machines, identify the basic parts of a horizontal milling machine, and describe the functions of the parts. When properly set up and operated, the horizontal milling machine is a versatile, time-saving machine used in producing machine parts.